Hello, friends. I am Satish Lele. I am a chemical engineer. I am working in field of piping for last 30 years. This video is part of my chemical process piping channel on YouTube. This video is about flange gaskets. The gasket is a mechanical seal which fills the space between two mating surfaces. It generally prevents leakage from or into the joined objects while under compression. Gaskets fill mating surfaces on machine parts where they can fill irregularities. Gaskets are commonly produced by cutting it from sheet materials, such as gasket paper, rubber, silicone, metal, cork, felt, neoprene, nitrile rubber, fiberglass, Teflon or plastic polymer. Gaskets for specific applications, such as high-pressure steam systems, may contain asbestos. However, due to health hazards associated with exposure to asbestos, non-asbestos gasket materials are used when practical. It is usually desirable that the gasket be made from a material that, to some degree, yields such that it is able to deform and tightly fills the space it is designed for, including any slight irregularities. A few gaskets require an application of sealant directly to the gasket surface to function properly. Some piping gaskets are made entirely of metal and rely on a sealing surface to accomplish the seal. Flange gasket. A flange gasket is a type of gasket made to fit between two sections of pipe flanges that are flared to provide higher surface area. Flange gaskets come in a variety of sizes and are categorized by their inside and outside diameter. There are many standards in gaskets for pipe flanges. The gaskets for flanges can be divided in major different categories. Sheet gaskets. Sheet gaskets are simple. These are cut to size either with bolt holes or without holes for standard sizes with various thickness and material suitable to media, temperature and pressure of pipeline. It is a case of material punched out of sheet. This leads to a very crude but fast and cheap gasket. In past, the material was compressed asbestos, but in modern times a fibrous material such as graphite is used. These gaskets can fulfill many chemical requirements based on the inertness of the material used and fit many budgetary restraints. Common practice prevents these gaskets from being used in many industrial processes based on temperature and pressure concerns. Ring gaskets. Ring-type joint gaskets are mostly used in offshore oil and gas pipelines and are designed to work under extremely high pressure. They are solid rings of metal in different cross-sections like oval, round, octagonal, etc. Sometimes they come with hole in center for pressure equalization. Solid material gaskets. The idea behind solid material is to use metals which cannot be punched out of sheets but are still cheap to produce. These gaskets generally have a much higher level of quality control than sheet gaskets and can generally withstand much higher temperatures and pressures. The key downside is that a solid metal must be greatly compressed in order to become flush with the flange head and prevent leakage. The choice of material is more difficult because metals are primarily used, so process contamination and oxidation are the risks. An additional downside is that the metal used must be softer than the flange in order to ensure that the flange does not warp and thereby prevent sealing with future gaskets. Even so, these gaskets have found a niche in industry. Spiral wound gaskets. Spiral wound gaskets are also used in high-pressure pipelines and are made with outer and inner rings of stainless steel and a center filled with spiraling wound stainless steel tape wound together with graphite and PTFE, which is formed in V-shape. Internal pressure acts upon the faces of the V, forcing the gasket to seal against the flange faces. Spiral wound gaskets comprise a mix of metallic and filler material. Generally, the gasket has a metal, normally carbon-rich or stainless steel wound outwards in a circular spiral. Other shapes are also possible, with the filler material which is generally a flexible graphite wound in the same manner as starting from the opposing side. This results in alternating layers of filler material and metal. The filler material in these gaskets acts as a sealing element, with the metal providing structural support. These gaskets have proven to be reliable in most applications, and allow lower clamping forces than solid gaskets, albeit with a higher cost. Constant feeding stress gasket consists of two components: a solid carrier ring of a suitable material, such as stainless steel, and to sealing elements of some compressible material installed within two opposing channels, one channel on either side of the carrier ring. The sealing elements are typically made from a material like expanded graphite, expanded PTFE suitable to the process fluid and application. These derive their name from the fact that the carrier ring profile takes flange rotation or deflection under bolt preload into consideration. With all other conventional gaskets, as the flange fasteners are tightened, the flange deflects radially under load, resulting in the greatest gasket compression and highest gasket stress at the outer gasket edge. Since the carrier ring used in constant feeding stress gaskets take this deflection into account when creating the carrier ring for a given flange size, pressure class, and material, the carrier ring profile can be adjusted to enable the gasket feeding stress to be radially uniformed across the entire sealing area. Further, because the sealing elements are fully confined by the flange faces in opposing channel on the carrier ring, any in-service compressive forces acting on the gasket are transmitted through the carrier ring and avoid any further compression of the sealing elements, thus maintaining a constant gasket feeding stress while in service. Thus, the gasket is immune to common gasket failure modes that include creep relaxation, high system vibration, or system thermal cycles. Double-jacketed gaskets. Double-jacketed gaskets are another combination of filler material and metallic materials. In this application, the tube with ends that resemble a C is made of the metal with an additional piece made to fit inside of the C, making the tube thickest at the meeting points. The filler is punched between the shell and piece. When in use, the compressed gasket has a larger amount of metal that the two tips where contact is made due to the shell and piece interaction, and these two places bear the burden of sealing process. Since all that is needed is a shell and piece, these gaskets can be made from almost any material that can be made into a sheet, and a filler can then be inserted. This is an effective option for most applications. This chart shows nominal sizes for gaskets. The pipe size, gasket inside diameter, gasket outside diameter for different flange classes is given in inches. The pipe size, gasket inside diameter, gasket outside diameter for different flange classes is given in inches. This chart gives recommended design parameters. 3 considerations for force on gaskets. And force originates from the pressure of confined gases or liquids that try to separate the flange faces. Gasket load is the function of the molding which applies force on the flange faces to compress the gasket and withstand internal pressure. Internal pressure is the force which tends to move, permeate or bypass the gasket. Thanks for learning. If you like this video, please give a like to my channel and subscribe it.